Hello, 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 and welcome back to a sort of half episode of Kerbal Space Programming. I kind of ran out of time to get a full episode up today, but I wanted to talk about something that I encountered while writing our gather science function for our upcoming mission to Minmus. So I was very excited about version 0.19, and I was trying to rewrite this in anticipation using the enumerable library that I talked a little bit about in my previous video about function delegates and why they're really, really cool. In particular, this lets us manipulate, this enumerable library lets us manipulate lists and in all sorts of convenient ways. And so I was really excited about gathering science, because if we think about what do we want to do? Well, all we want to do is we want to get all of the parts that have a science module. So we have a list of all of our parts. We want to get just those that have a science module, and then we want to get the actual science module from those parts. And then we want to say, all right, for each of those modules, do the science, please. And these are just some list operations. We start off with a big list of all the parts. We want to shrink it down to a portion of the list. Then we want to take that list and transform it into a list of modules instead of a list of parts. And then we want to do something for each element on that list. And so that's what I've written here. I've got local science parts is enumerator select ship parts, and then we're passing in a function that tells it whether or not it has a science module. And I've got those all written down here. And then once we've got the science parts, we get the science module. We say, all right, I want to map this list of science parts to the result of calling get science module on all of those parts. And then finally I say, all right, for each element in the science modules, I want to run that science module. And so that was supposed to be very, very exciting. And I find myself a little bit disappointed with this because it's a little bit unwieldy. And let me explain what I mean. I'm going to pull this out and jump over to an empty file, and we can go ahead and take a look at it here. So this is the part that I'm unhappy with. Not that these functions exist, because those are very, very simple. They just describe whether or not something has a module. It'll get the module, and then it'll run the actual science. But I'd like to actually go ahead and shrink this up, because this is a bunch of code that's a little unwieldy. And in particular, these temporary variables don't really need to be here. I'm not going to do anything with them. Why don't I just apply them as the arguments here? So we can think about this. If I go ahead and reformat this a little bit, we know that if we have a variable and we're only declaring it here, we can just replace it in that definition. So I'm just going to delete forward to the enum, delete tilde enum, and then yank that, paste it in here, and throw that in instead. Right? And so now this should do the exact same thing. Let me go ahead and delete that. So we're just supplying that argument where we used to have, what do we call it? Science modules, and we're just actually getting the science modules in line here. And of course, if we're doing that, we can do the same thing with this science parts definition. So I don't like having to save this variable up here for no reason. So I'm going to go ahead and delete to enum again, and delete this, and paste that in there. So delete to enum, and replace that with a comma. All right, so now we've got that, and this should still work syntactically. I'm not going to go ahead and test this because some of the code is missing in this example, but we can continue formatting that out. And there we have our very nice, super readable version of what we were just doing. We select of the parts those that have a science module, then we map those parts to the actual module, and then we run the science module for each of those. Now, if you look at this and you squint, or even if you don't squint, it looks pretty terrible. And the reason for that is that we have to read this thing from the inside out. Now, that's not how humans like to read stuff. What I would love to do is to go, okay, we've got ship parts, something, 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 to, select something, 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 to map to something, 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 to each. Right? We want to read things left to right. And when we have these functions in here, then it gets a little bit tricky to understand what's going on. So I'm not a fan of this format, but what are some of the alternatives? I want to take a look at two different languages and kind of how we would write this code if we were writing in those languages. So I'm going to go ahead and paste in an example from Ruby. So this is how you would do this in something like Ruby. You'd say ship parts, you'd say dot select, and you would pass it what's known as a block or a lambda, which is kind of similar to our function delegates. We won't kind of get into the details because we're not really talking about Ruby. And then you call map on the result of that. and you pass in another lambda, and then you call each. Or if you wanted to, you could actually supply this this whole thing in line. You could say select part has module something, and then close it up, and then just continue this on. And this is actually a little bit more understandable, right? If we think about how this works, or at least we look at how this is representing itself. We start off with this thing, then the next line, we filter it, then we transform it, and then we do each. And that's a lot more readable than this inside out, upside down craziness. Somebody's been watching too much OK Go. Anyway. So what would this look like if we wanted to do this in KerboScript? Well, I've gone ahead and written up a quick example of how that could look. So we have ship parts, and we could go select and has science module, and map get science module, and each run science. Now there's some problems here though. This is very readable, this is understandable, this makes sense, but there's some issues. One is that ship parts is not a lexicon, and we're trying to pretend that it is. So we'd have to wrap this using some sort of function that creates a lexicon. But then if we think about this, okay, so we wrap this into something, some sort of, magic thing is a lexicon, and it's got a select key that is some function. And I'm just using these arrows to, this isn't correct syntax, I'm just using it to represent what we've got. So we've got wrap that'll return us something, and it's got select. Now the problem though is that select also will have to return back a magic thing, right? Because we'd need map to exist here as well to be a function, and each would have to exist here. And they would also have to return back this magic thing. And what we're really talking about here is some sort of list wrapper. That is something that can pretend to be a list and can kind of hold the value of a list and transform it according to these things, but then return itself because all of these select and map and each things exist on top of that object. So this is a little bit tricky because, one, we've got to wrap stuff here, but then also, if we think about this, then it means that when we get this stuff out, we never know at this point, well, maybe you're going to call select or something later. Maybe you've got more to do. So I don't know, I can't just give you back the list here. This has got to return back that magic thing, and this has got to return back that magic thing, and this has got to return back that magic thing. Because there's no way for me to predict in advance, are you done? Are you done chaining all of these things? Or can I give you back the list? Or do I need to give you back this magic thing that has these available methods in it? We don't know, and so we'd have to do something like, say, done, give me value, and call that here. So that's a little frustrating. Now, the other thing to keep in mind, though, is that we've got this wrap thing, and this wrap is just assuming about ship parts that it's a list or something and that it can have these values. Maybe we tried to wrap a string, or we tried to wrap a number, and select and map and each don't make sense for those values. Well, we're not being explicit about what's being called here. We're just saying this magic thing has some sort of select method. We're not going to, it just exists alongside with the object. It doesn't describe the behavior. It describes some characteristic that the object has. So we're going to avoid this sort of syntax just because it gets a little tricky. And we want to make sure we don't have to carry around these list-alike wrapper things. So let's look at a different language and think about how we can take a different approach. So I'm going to go ahead and paste in. This is some pseudocode from how you might do this in a language called Elixir, and I could have the syntax wrong. I didn't double check it, but you'd take ship parts, and then there's this weird little stick figure saluting at you, the headless salute, and it's and then we've got enum.select, and then we've got this other thing here, and this is pretty similar to what we're talking about with function delegates. I would say has science module, and then we're gonna salute that to enum map get science module, and we'll salute that to enum each. And now what's happening here is quite interesting. This is called the pipeline operator, and I think it is my favorite thing in all of computer science, at least for now. And basically all that it does is if we have, let's say that we have some sort of string, and we want to apply some transformations. So I'm going to say reverse the string. Oops. And let's say uppercase the string and reverse the string again, because I'm not very imaginative. Now this has that same problem of we have to read it inside out. We've got to look at the string, then we've got to go, okay, then you're reversing it, and then you're uppercasing it, and then you're reversing it again. Whereas what you would do in Elixir is you would say string, reverse, uppercase, reverse. Of course, I probably should have used different words because now this is a little bit confusing. But what it does is it says, all right, take this first result and take the output of it, and then use that as the first argument. So if we say, let's say arg is string, then would say, whoops, arg is reverse arg, and then arg is, whoops, is uppercase arg, and et cetera, et cetera, et cetera. So all this is doing, and in addition, it can accept these second arguments. So let's say that we had reverse, we wanted to reverse by word or something, and our function accepted that as an argument. Well, what Elixir does, it's really sneaky, is when it's looking at this line, it knows, because there's the pipeline operator, that we shouldn't just call reverse with this argument. It's going to sneak in the result of the previous argument here as sort of a hidden first argument. And this is really, really useful. It means that we can write everything in a linear way, but we don't have to make sure that what it returns has those values. Because remember, in this Ruby version, ship parts had to have a .select method, and then whatever that returned had to have a .map method, and whatever that returned had to have a .each method. Here we don't care if it has that, because we, instead of calling it on the return value, we're going to take the return value and use it as the first argument. So this is a much more viable approach. And if we think about how this could work in KerboScript, this is kind of the syntax that I came up with, that we have ship parts, and we're going to call this inside a function, or we're going to treat ship parts as a function, and we're going to say select, and we're going to say has science module, we're going to say map, get science module, each, run science. And let's go ahead and delete off all of this code now, and think about how we could implement this. Let's think about what is wrong with how this currently works. And one of the first things that we're going to notice is that, well, ship parts is not a function. So if we try and call this as a function, this is what it's doing, it's going to get mad. So we have to do some sort of wrapper. So I'm going to go ahead and say pipeline ship parts. So now, okay, now we're not restricted by the same limitation, because whatever this returns could be a function. In fact, it has to be. And instead of insisting that this thing has to have some sort of select key, we're just going to make sure that we pass in the full definition of whatever transformation that we're trying to do, and then whatever additional arguments. And remember, just like with the example we saw before, our pipeline is going to be sneaky. It's going to slip in the result here, and it's going to slip in the result here of that operation, and the same thing down here. So we can chain these things infinitely, and everything will be just fine. So let's think about how we can actually write this. This syntax will run, but of course it's not going to work because we haven't defined stuff. So I'm going to go ahead and write a function. Whoops, what did I just do? I'm going to go ahead and write a function called pipeline that can actually do this for us. And of course it's got to take some sort of initializer value. Let's call it value. All right, so there we go. We've got a function it's going to grab a value. And just for fun, let's go ahead and start actually running this. So I'm going to go ahead and run libenum, because that needs to exist. And I'm just going to create some quick function definitions. Has science module, and this takes the parameter part, and it's just going to return true. I'm just putting in some stubs here. Change this to get science module. And instead of getting the actual module, I'm just going to return part name, and function run science is going to go, it takes in a module, and then it's going to print M. There we go. So instead of actually running science, it's just going to print itself out. So this is just some bare bones to get this to a point where it should run. So let's go ahead and try and do that. Oh no, connection closed. Why connection closed? That's interesting. Why connection closed? Let's run you again and see what. Oh, there we go. Okay, it just the argument disappeared. Oh yeah, it doesn't like me running libenum for whatever reason. I'm not entirely sure why. But now that we've run it, it already exists. So, okay, there we go. Incorrect number of arguments. Expected 0 but found 2 on line 7. So it's mad about this select line. All right. Well, that sort of makes sense, right? Because, this isn't a function. This result of calling pipeline isn't a function, and we're trying to call it as though it were a function. So I'm going to call this function the unit function. And we'll go ahead and just return back that unit function as a result from calling the pipeline. There we go. Okay, so we're making progress. Different error now. Now the error is that the number of arguments passed in didn't match the number of declared parameters. Well, that's frustrating. All right, that's fine. We'll go ahead and say that this is going to take in 2 parameters, A and B. Go ahead and run that. Expect what? Okay, now map is angry. All right, so this passed, right? So we got past this line, and now we've got this line map. And this makes sense as well, because now whatever we called here, this unit function, was an empty response, and now it's trying to call that as though that were a function. So let's say instead return a new unit. We'll just return another function. We'll just keep passing down functions. And the program ended. All right, the program ended. Is that good? I think that's good. All right, yeah. Okay, connect. What are you doing? Telnet is occasionally tricky. But okay, so the program ran and it ended and it didn't complain. So there we go. Wonderful. It is working, except it's not actually doing anything, right? All we're doing is we've created this pipeline thing that has a value and has some sort of unit function inside here and then returns itself. So we could call this an infinite number of times. We could say pipeline, 2, and then we could just call it over and over and over and over and over and over and over again, and it's never going to run out of these nested functions. So that's at least something. It means that the syntax will work. Of course, it'll only work if we have these 2 arguments. But of course, we don't necessarily want to rely on those being 2 arguments, right? Because we could have something like enum.reversed or something like that that just doesn't need a second argument. It's going to have that first argument. So I'm going to go ahead and say parameter operation. And then we have to deal with optional arguments. And this is something that we get in version 0.19. And this is, I'm going to say arg1 is, let's see, yeah, no. And except it's not arg1, is it? Right? Because if we think about this, we had that whole sneaky result that we're implying here, an implied sneaky variable. So I'm actually going to call this arg2. Now, we could go ahead and add an additional optional arg3, but I'm not going to worry about that. We're just going to leave that in there as the arg2. So now here's the tricky question. What are we actually going to be doing inside here? These accept the arguments, and it's returning out something again. But what I really want is a function that's going to keep around the new value of applying this operation. So instead, let's say that I were going to return a unit with the result of applying the operation to the value and arg2. So I'm creating a new unit. We're treating this unit like it's like this unit function like it's just a constructor, like it just holds in some stuff. Now that's going to return a whole bunch of errors. There we go, a whole bunch of errors. Good. You can't call this function was declared in the interpreter. Okay, that's a different error. I think we may need to reboot at some point to fix that, but we'll get past that. what we want to actually worry about is now we can sort of manually figure out, well, this is not going to be okay, because we're trying to call this thing, and I think this ends up being an infinite loop. Really what we want is something that's going to just hold that value. So we're going to say parameter value, and we'll take this value just so it's not confusing. Let's see, start value, right? We'll call that. We'll say this function unit is going to take a value, and that's going to have a value, and it's going to return back some other function that lets you call this operation. I'm going to call that bind. No, I'm not going to call that bind because that could be confusing. Let's see. We'll call it advance. Of course, so we've got to call function advance, and then we'll say return advance. And what this advance operation is going to do is it's going to give us back a new unit based on that value. So it's doing this stuff inside here. Now this can get a little bit confusing. What we're doing is we're treating this unit function as though it's just create some random space where this value can live. And then we're going to say return back some function that lets you change that value. Except we're not really changing that value. We're creating a new unit function that holds a new value. So we've got return advance. That's great. And down here we just got to return unit start value. And let's go ahead and try and run this and see what happens. Could be that there's still... Alrighty, so I was getting some minor errors that I think were just due to me trying to use the enumerable library as part of this telnet thing over and over and over again. So I've tidied this up a little bit. We still have this pipeline. It takes a start value, and it creates a function called unit that just wraps around a particular value. And we have this function next that takes in an operation, and it's going to create a new unit, which is going to wrap around the new value that's created by applying the operation to that value. And then it's going to return that next function. And then here we're returning a unit with the value of the starting value. So let's think about how we can use this. I'm going to write a function called, let's see, add foo. And this is going to take in a parameter string. Well, we'll call it str, and we're going to return str plus foo. So that's all that does. And now let's think about how we can actually use this. I'm going to go ahead and say print pipeline hello. And because this is a pipeline and it's returning this new unit wrapper every single time that provides this next function, we can go ahead and just say add foo. And I can do this over and over and over again. And now if we go ahead and run this, oh, no. Now we have a bit of an issue. You see what it's actually printing out is not the value, it's printing out some user delegate, and this is meaning that it's printing off the function. Because what we're getting back here is still a function, right? We're getting back something that we could call again, because we have to, because it doesn't know when we're done calling out these functions. So what instead I'm going to do is I'm going to go ahead and call with an empty with no operation at the very end. And we'll use that to signal that we're actually done. We don't need to go ahead and continue returning a new unit, pipeline unit. We're just going to return the actual value. So what we have to do here, though, is because it's expecting us to provide an operation, is we're going to say operation is null. Now I'm going to say if operation equals null, return value. So what we're doing is we're setting a default value for this operation so that if we don't pass anything in, it's going to be set to null. And we're going to say, all right, well, if it is null, then just return the value. We don't need to create a new unit that wraps all of this stuff. So now if we go ahead and run this, there we go. Hello, foo, 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 foo. We get that final result by calling this thing here. If we leave that off, then we get our function delegate right there. So, okay, now this is not exactly what we were doing before because we were doing stuff that actually had some sort of argument. So let's go ahead and change this add foo thing to, let's see, add string. We've got some delegate, and I'm going to say add string pie and cake, and we'll just leave it there. And we'll leave on that final function call to say, I'm done, go ahead and give me back the response. Of course, we've got to write that function real quick. Add string. And this, of course, is going to have to take two parameters. It's going to take parameter of the string and the parameter of the thing to add, whatever that may be. And I'm going to return string plus a space plus thing to add. And let's go ahead and try and run this. And now we have an issue because we didn't match the number of arguments that were expected. Now that's fine, because what's happening is this next function is expecting just the one, just the operation. Well, we can go ahead and continue to declare new parameters. So I'm going to declare arg2 is null, and do that. And let's see, now we have to be a little bit careful when we're creating this, because if the operation expects that to be there, then we've got to make sure to pass it in. But if it's null, then we don't want to pass it in. So what can we actually do? Because what we could do is we could say if arg2 equals null, then return unit operation value, what we did before. Otherwise, return unit operation value and arg2. We could do that. And that should work if I go ahead and run that. You do. Hello pie cake. Wonderful. And we could even do that, and we could bring back our add foo. And now we could put that in parameter string, return string plus foo. And now we should be able to support both of these. So I can go add foo with no arguments and leave that add string in there. We do that. Hello pie foo cake. Wonderful. So now we support these multiple arguments. But instead, what I want to actually do, just to make things a little bit cleaner. Now, we can't have an infinite number of optional arguments, so we're going to have to cap this at some point. But let's say that we want to be able to support up to, some arbitrary number of arguments. Well, what we can do is use something that's a little bit fancy. Actually, we'll go ahead and just leave it at, we'll go ahead and just leave it at 2 for now, because I'm not going to code this all up in this episode, but just to kind of show you the example, is we can use this bind operation that we have. So the operation is a delegate, it's a function delegate, and we can call bind on it. And what that means is take the function that it is and apply this argument to it. Now don't run it right away, but next time you call it, use this as the first argument, and then let me go ahead and specify the next ones. So what we could say is if arg2 is not null, then set operation to operation bind. Actually, we're going to have to go operation bind value, because the first argument is always going to be the value, and set operation to operation bind arg2. Then we can get rid of all of this, and we can say operation with no arguments. So what bind is doing is it's just applying that thing and saying, anytime now that, well, actually, hang on, let me go here. Set operation to operation bind value. So if we have some function that takes, A, B, and C, and I say f bind, let's see, G equals bind, f bind 5. Well, and that means that I now have this function G that takes B and C, and if when I call it, I can call it like this. What it's going to do is it's going to call f of 5, B, and C. That's a little bit confusing, but basically it's just saying pin this thing to the first argument. And because we can call this multiple times, I can do f bind 5, bind 6, bind 7. Well, and that's exactly what we're doing here, is we're just saying if arg2 is not equal to null, then go ahead and add on an additional argument. Otherwise, we're just going to bind it to that first value. And what we could do is basically just extend this out to have some sort of arg3 and then just, go through and probably write a loop to do exactly this, that we go ahead and just tack these on as we go through and say, all right, for any of these that aren't null, go ahead and add them on as potential arguments. So anyway, this is kind of what I've been playing with. I'm excited to go ahead and rewrite a bunch of our code to actually use this sort of pipeline strategy, because I think this is a lot easier to read, especially when we're looking at stuff like running all of the science of the parts, rather than having all these for loops and stuff that are not necessarily the easiest to understand. We can have something that's going, all right, we know exactly what's happening here. So we're going to say, all right, we're going to select those that have a science module, get the science modules from them, and then run science. So we don't have to try and figure out what exactly is going on in this nightmare of code. Anyway, so we will get back to our Minimus mission in the next episode. Until then, have a great one. Cheers.